In this lesson, we will define non-positive exponents. We will do this by proceeding through specific steps. First, we will understand the reason behind the definition of a zero power. For example, what should we understand when we read 5 to the 0 or negative 2 to the 0? What do these numbers mean? Then, after we define a zero power, we will move to understand a negative 1 power. What must 5 to the negative 1 mean? Or 2/3 to the negative 1? Once this is done, we will finally go to any non-positive exponents. For example, we will look at 2 to the negative 3 or negative 5 to the negative 2. We will even look at non-negative rational exponent as in negative 8 to the negative 2/3. At each step, the motivation to define a new exponent is to conserve the various properties of exponent. Therefore, to master the content of the first lecture, you must be familiar with the properties of exponent. Let's recall these main properties right now. The first property involves the product of two exponential with the same base, a to the n times a to the p. In this case, you don't change the base and you add the power. I am assuming n and p to be natural number, except 0. We haven't defined a power 0. But actually, because of our previous lesson, we could also assume n and p to be rational number, positive. Okay? The second property involves raising an exponential to another power. In this case, you don't change the base and you multiply the exponent. The third property deals with raising a product to a power. For example, a times b to the n. This is a to the n times b to the n. So in this case, the power distributes over the product. Please be very careful. This is not true when you raise a sum or a difference to a power. In this case, the power does not distribute over a sum or a difference. For example, when we had a plus b squared, we saw it recently. This is a squared. There is a b squared, but there is also a double product. Same with a minus b squared. There is an a squared, and there's also a plus b squared, but in the middle, we have a double product. So you see, you just don't distribute the power over the sum. That is not true. There is a double product in the middle. Okay, let's recall two other properties before going further. So this time, I want to raise a ratio to a power. How do I raise a ratio to the power? Simple. You raise the numerator to that power and the denominator to that power. Finally, the last property we have not often used, but you should have studied before. What happens when you take the ratio of two exponential with the same base, a to the n over a to the p? In this case, you will find an exponential with a base a, and the exponent is the difference of the exponents, okay, n minus p, a to the n minus p. For right now, we can assume n is above p in order to guarantee that this power is positive, simply because we have not yet defined a zero or a negative power. But before the end of the lesson, we will no longer need this assumption. So let's proceed right now with the first step. How do we define an exponential to the power of 0? Before we look at the definition, I want to understand the motivation behind the definition. So let me look at the number 2 to the 0. This is a number. I don't know which number it is, but I know it is a number. So here's the way I'm going to extract its meaning. Let's take to the 0 and let's multiply it by 2. Now, why do I do that? We will see. 2 is the same as 2 to the first power. Now, to understand the meaning of 2 to the 0, it is important to recall what I'm trying to do. I'm trying to keep the properties of exponent. In this case, I have a product of two exponential, right here, with the same base. And what do you do in this case? You add the exponent, okay? So I want this to be true. I need this to be true. Now, 0 plus 1 is 1. And so this is 2 to the 1. And 2 to the 1 is 2. So what do we have? I had this number. I didn't know what it was. I multiplied it by 2. And I found 2. Now, what must it be? You take a number, you multiply by 2, and you find 2. You don't have any choice for that number, right? That number better be 1. That's it. This is 1. And so right now, I'm going to say 2 to 0 must be 1. You can try this with any other number, and you will see that we need to define anything to the 0 to be 1. All right, let's move now to a negative exponent. So for this one, for example, I'm going to look at 5 to the negative 1. Again, this is a number. It's an exponential notation, but I don't know what the meaning of this number is. So let's take 5 to the negative 1. And to extract its meaning, I'm going to multiply these by 5. Okay, so what is this? 5 is the same as 5 to the first power. Again, I want these property to be true. I am multiplying right here two exponential with the same base. So I want to be able to add the power. So this is negative 1 plus 1. But what is negative 1 plus 1? Is 5 to the 0. Right before, we've defined a power 0 as 1. So this is 1. Okay, let's backtrack a little bit. What did I have? I had a number, I didn't know its meaning, and I multiplied by 5, and I found 1. So what must A be? Well, A must be 1 over 5, right? You divide by 5 both sides, and it's got to be 1 over 5. Okay, so this is the reason to define 5 to the negative 1 as 1 over 5. I have given meaning to a negative 1 power. Finally, how can we define a number to a negative integer? For example, 3 to the negative 2. Well, here I'm going to write negative 2 as negative 1 times 2. Then I'm going to use a property that tells me that a to the x times y is the same as a to the x to the y. So 3 to the negative 1 times 2 is 3 to the negative 1 squared. I want it to be this way, right? This is a desire. 3 to the negative 1, we know what that is. This is 1 over 3. And 1 over 3 squared, remember when you raise a fraction to a power, you raise both numerators and denominator to that power. So it is just 1 over 3 squared, okay? And so looking at this last equality makes me want to define a to the negative n as 1 over a to the n. Okay, so let's go over the three defining statements and let's practice some problems. Here we go. These are the three definitions we just went over. What is a 0 power? It's just 1. Anything to the 0 is 1. What is anything to the negative 1 power? It's just the reciprocal of that number. And finally, what is anything to a negative n power? It's a reciprocal of that number to the power of n. Let's practice some examples now. Okay, you will see how simple that is. What do you have to do? Rewrite without a negative exponent. Do not use a calculator. What is 5 to the negative 1? 1 over 5. Finished. What is 3 to the negative 3? So this is the negative right here is telling you to do 1 over 3 cubed. No more negative power. Do you know 3 cubed? Absolutely. 27. See? Very simple. Next set. All right. Negative 5 to the negative 3 power. So again, the first thing you have to look at is this negative sign right here. And this negative sign is telling you 1 over. Now, 1 over what? The base hasn't changed. And then the power becomes positive. That's it. What is negative 5 cubed? It's negative 125. Done. Negative 6 to the negative 1 power. What the negative 1 is telling you to take the reciprocal of negative 6. That's it. Usually we write it like that, negative 1, 6. Next set, 2 to the negative 4. That's just 1 over 2 to the 4. 2 to the 4 is 16. Here we go. Negative 2 to the negative 4. The first thing I'm going to do is take care of this negative sign right here, which tells me to do 1 over. Now, keep the base, don't change the base, and the negative 4 becomes plus 4. And now, what's the base of my power 4 is negative 2. Negative 2 to the 4 is 16, so this is 1 over 16. Next one, here you have to be careful. What does a negative 4 applies to? Just the 2, not the negative sign, right? This is out of the base. So this means negative, and then 1 over 2 to the 4th. So this is negative 1 over 16, okay? Again, be careful what's the base of the exponent. Next set of examples. Now, in the next set of example, my bases are fraction, rational numbers. So how do we deal with them? Let me show you on the first one. There is a shortcut. I'm going to show you on the first one, and then we'll apply the shortcut, okay? So I have 2/3, and I'm raising that to the negative 3. Negative 3 is negative 1, and then raised to the cube, right? You multiply the powers. Now, what does negative 1 means? A to the negative 1 means the reciprocal of A. That's all it means, negative 1. Negative 1 means reciprocal. So what is 2/3 to the negative 1? It's a reciprocal of 2/3. The reciprocal of 2/3 is 3/2. So that simply means 3/2 cubed. And this is how you can remember a negative power applied to a fraction. If you take A over B and you raise it to the power of negative n, this is something very simple. You flip the fraction, b over a, and you turn the power into a positive power. That's a shortcut. That's it. Now, a fraction to a power, you have to raise both numerator and denominator to that power. 3 cubed is 27. 2 cubed is 8. That's it. Done. Let's go over example number 9. So I'm going to go with the shortcut, right? What do? I take the reciprocal of negative 8, 9. The reciprocal of negative 8, 9 is negative 9 over 8. I flipped my fraction. It doesn't affect my sign, okay? And then the power becomes positive. Now, what is negative 9 8 squared? That means negative 9 8 times negative 9 8, right? So it's going to be a positive number. You square the top, that's 81, and you square the bottom, 64. That's it. Next series of example. Here we go. 5 over 4 to the negative 2. So let's take care of the negative sign by flipping the fraction, 4 over 5, and then the power has turned to be positive. So this is 4 squared over 5 squared, 16 over 25. Done. What is 5/3 to the 0? Don't forget that. It's just 1. Next one. Okay, be careful right here. The negative sign is not part of the base, right? So let's take care of this negative power first. So the negative sign doesn't change. Let's take care of the negative power. The negative power tells you to take the reciprocal of 3/2. That's 2/3. And then the power becomes positive. And then you raise both sides of the fraction to the 4th power. So it's 2 to the 4th over 3 to the 4th. So this is 2 to the 4th is 16. 3 to the 4th is 81. Here we go. I'm going to leave 13 for you. Let me move on to the next set of examples. In this example, I have now a negative rational exponent. So I can look at it as 8 to the negative 1 to the 1/3, but I can also look at it as 8 to the 1/3 to the negative 1, right? Let's deal with the second way. It's going to be slightly faster. What is 8 to the 1/3? It's a cube root of 8 to the negative 1 power. I haven't yet taken care of the negative 1 power, right? But the cube root of 8 is 2. So it's just 2 to the negative 1, which means the reciprocal of 2. So this is 1/2. That's it. Pretty simple, right? Let's move on. Okay, here's another one. Negative 32 to the negative 1/5. So this is negative 32 to the 1/5 to the negative 1. All right, I'll do this one last. Let me start with what's inside. Negative 32 to the 1/5 means the 5th root of negative 32. The 5th root of negative 32 is negative 2. Negative 2 to the negative 1 is 1 over negative 2, or negative 1/2. That's it. Next one. Okay, here we go. 25 to the negative 1 half. That means 25 to the 1 half to the negative 1. 25 to the 1 half is a square root. Remember, power of 1 half means square root, okay, of 25. Square root of 25 is 5. 5 to the negative 1 is 1/5. If you want to go a little bit faster than me, please by all means do so, okay? 16 to the negative 1/4 is 16 to the 1/4 to the negative 1. 1/4 fourth root. Fourth root of 16 to the negative 1. Fourth root of 16 is 2. 2 to the negative 1 means 1/2. All right, next series. Okay, number 18 and 19. For number 18, please be careful what's in the base. Negative is not in the base, okay? So it's negative, and then we have 16 to the 1/4 to the negative 1, right? 16 to the 1/4 to negative 1. 16 to the 1/4 is the fourth root of 16. That is just 2, right? Fourth root of 16 is 2. 2 to the negative 1. So it is negative 1/2. All right? This negative is the same as that. Nothing happened to it. It was not in the base. On the other hand, for number 19, the negative is in the base. So be careful right here. What does that mean? This is negative 16 to the 1/4 to the negative 1. Negative 16 to the 1/4 is the fourth root of negative 16 raised to the power of negative 1. And the fourth root of negative 16 is not a real number. We've covered that in the previous lesson. You cannot find the real number, raise it to the power of 4 and find negative 16. The index of the root is even, therefore you cannot have any negative numbers inside if you're dealing with real number. Let's move on. I'm going to let you do number 20. Let me move on to number 21. So what do we do with 21? We have 8 to the negative 4/3. I'm going to break my negative part of the exponent. I'm going to do 8 to the 4/3 first, and then I'm going to raise that to the power of negative 1. Now, I'm going to take on the side 8 to the 4/3. We've done that in the previous video. This is the cube root of 8, 8 to the 1/3, to the power of 4. The cube root of 8 is 2. 2 to the power of 4 is 16. Okay, so 8 to the 4/3 is 16. So this is 16 to the negative 1, just 1/16. That's it. Don't go too fast. It's not too difficult. Let's move on. All right, let me do number 22. You will do number 23. In number 22, what do we have? We have negative 8 to the 4/3 to the negative 1. Okay, right? To the negative 4/3. So let's take what's inside on the side and let's do it. Negative 8 to the 4/3. This is negative 8 to the 1/3 to the fourth power. 1/3 means cube root, and the cube root of negative 8 is negative 2. So it's negative 2 to the fourth power. Negative 2 to the fourth power is 16. So again, now we have 16 to the negative 1, same thing as before, 1/16. All right, let's move on to the next series of example. So in the next series of example, I have to rewrite my expression without a negative exponent. Please pay attention what the base of the exponential here is. What is the base of this exponential? It is just x, not 2, right? So that means 2 times x to the negative 1. I know what to do with x to the negative 1. X to the negative 1 is just 1/x. Usually this is written as 2/x. Okay, we multiply the fraction and this is 2/x. Next one. Okay, again, please be very careful. What's the base of the exponential? The exponential is right here. Negative 4 is not part of the base. So this is negative 4 times a to the negative 2. We know what to do with a to the negative 2. Negative 4 times 1/a squared, which again, we would write it as negative 4/a squared. All right, next set of examples. Here we go. Negative 3, y to the negative 3. Again, this is not part of the base right here, right? So this is negative 3 times y to the negative 3. So this is negative 3/y cubed. I went a little bit faster here. I just brought that y to the negative 3 down to the denominator. This one, now, on the other hand, right here, what are you raising to the power of negative 2? The base is 2x, right? So this is just 1 over 2x squared, right? This is what you do when you have a to the negative n. It is 1 over a to the n, right? That's what I did right here. So I'm squaring 2x, so it's just 4. You got to square the 2, right? 4 times x squared, 1 over 4x squared. All right, next examples. Next examples, 28. So we have the base here is negative 4a squared raised to the negative 2. So let's take care of this negative 2 power right here. So negative 2 power tells me 1 over, and then the base to the second power. That's how I take care of this negative sign right here. What's a base? Negative 4a squared. Please be careful right here. We've seen that. You got to distribute the power over the product here. So it is, here, I'll detail it. Negative 4 squared times a squared squared. We've seen that before. So it's 1 over negative 4 squared is 16a to the 4th. That's it. 29 is for you. Let me move on. Let me do the last one, 31. You will see it's not too difficult. Now remember here, when you have a fraction to a negative power, we just covered that at the beginning of the lesson, you flip the fraction and the power turns positive. You need to remember these properties, okay, guys? So here, I'm going to flip my fraction. I do have a negative power, right? So I'm going to flip my fractions, 2b cubed over 3a squared, and I'm going to turn my power positive. Here, the power has to go to the numerator, right? That cubed, and then the denominator, that cubed right here, and then the power distributes inside right here, right? So basically, at the end, what do we have? We have 2 cubed times b cubed cubed. Okay, that's for the numerator. Denominator, 3 cubed times a squared cubed. So what is this? This is 8 times, what do you do right here? You multiply the power, b9 over 27 times, here you multiply the power, a6. Okay? Okay, I know in the note there is one more definition, but before we go over it, I'd like you to be more familiar with the content I've just covered. I hope it was clear. Thank you for watching.